Hello everyone, and welcome to another video with Special Maths Academy. In this video, we'll be looking at the 19th problem from the Special Maths Contest 2024 of first round. Before I move on, don't forget to like, share, comment, and subscribe so that the algorithm knows we're doing something right. Okay, let's dive into this problem. ABCD is a convex quadrilateral with AB equals to 24 units, BC 15, CD 7, DA 20, and BD 20. Okay, so what is the length of AC? So let's just have a sketch of this diagram. So first of all, we'll ask ourselves, what is a convex quadrilateral? So a convex quadrilateral is a quadrilateral with no reflex angles. So for instance, if you have something like this, so this is a convex quadrilateral because there's a reflex angle at point C. Okay, at C. So, but we're dealing with a convex quadrilateral, so no reflex angles. So let's just sketch this. Probably not accurately, but let's just have something. Okay. Okay. So AB is 24 units, BC is 15, CD is 7, DA is 20. Okay. And BD is 20. Okay. So we want to find out what is the length of AC. Okay, so first of all, we can see that we have two triangles. When you have the side lengths known, so we have triangle ABD and triangle CBD. When you have side lengths known, we don't know any angle. Now, what does this bring to mind? It means we can try to see, can we apply um, cosine rule? Okay, so cosine rule is the go-to when you have all the side lengths and don't have any angle. So let's look at cosine rule. But first of all, let's label some of these angles. So let's say this is alpha, and let's say this is beta. Okay. So by cosine rule, cosine alpha is going to be equal to 24 squared plus 20 squared minus 20 squared all over 2 times 24 times 20. Okay, so let's simplify this. So 20 squared minus 20 squared cancels out. We have 24 squared over 2 times 24 times 20. So this will cancel 24. This is 1. So we're going to this 12. 4 going to this 5. And 4 going to this 3. Okay, so we have cosine alpha is equal to 3 over 5. Okay, and then cosine beta, 3 by cosine rule. So let me write that here. Cosine beta is going to be equal to, so 15 squared plus 7 squared minus 20 squared all over 2 times 15 times 7. So this equals to 225 plus 49 minus 400 all over 2 times 15 times 7. So let's try and simplify this. So we have 225 plus 49. This is going to be, so let me just, it's going to be 274. Okay. Now 274 minus 400, this is going to be negative 126. Yeah, so negative 126. Okay, so let's me erase this. So we have negative 126. Now let's see if we can simplify this. So 2 will go into this 1, 2 will go into this 63. 7 will go into this 1. 7 will go into this 9. 3 will go into this 5. 3 will go into this 3. Okay, so we have that cosine beta is equals to negative 3 over 5. Now we have cosine alpha and cosine beta of negative values. This is a convex quadrilateral. So it means no reflex angles. So it means the angles are in the range 0 to 180 degrees. But we have cosine alpha and cosine beta. So basically you have cosine alpha is equals to negative cosine beta. Okay. So this is only possible. So given the range, so the angles are in the range 0 to 180 degrees. So let me just put it here. So this is possible if and only if alpha plus beta is equals to 180 degrees. Okay. Now, at this point, those of you who are familiar with circle theorems will understand why the thumbnail of this video is the way it is. So it means this is a cyclic quadrilateral. So we can just draw a circle. So I mean the circle passes through all 4 points. Okay. Now this is cyclic quadrilateral. What theorem can we apply when we have cyclic quadrilateral? So there's something called Ptolemy's theorem. Okay, so I'll write it in red because it's very important. And in fact, I will also link for people who want to do extra reading. So Ptolemy's theorem. So Ptolemy's theorem simply states that, okay, so we have AB times CD, okay, plus BC times AD, okay, is equals to AC times BD. So this is Ptolemy's theorem. So first of all, remember that we know this is a cyclic quadrilateral because opposite angles are supplementary. So now we can apply Ptolemy's theorem here. So we remember we want to find the length AC. Okay, so we can apply Ptolemy's theorem. So I'm going to write at this top left corner. So we have 24, okay, times 7 plus 15 times 20 is equals to 20 times AC. Okay. So 24 times 7, that's going to give you 168. Let me erase this. Yeah. So 168. 15 times 20, that will give you 300. Okay. And this is equals to 20 AC. Okay, so 168 plus 300. This is going to be 468. Okay. Okay, so divided by 20. So 468 divided by 20 is equals to 23. So 234 divided by 10, that's basically 23.4. So that's going to be 23 whole number 2 over 5. Okay. So this is our final answer. So I hope you enjoyed this question. Don't forget you can read more about Ptolemy's theorem and cosine rule. Once again, don't forget to like, share, comment, and subscribe. And also don't forget that registration for the next edition of the Special Maths Contest is now open. So register for that exam and see you at the top. Goodbye.